G'day viewers, I'm going to pull these modules out. This is a power supply module for the computer. 240 volt primary, here we've got two 15 volt windings, 7 volt amps going there to the capacitors, some voltage regulators. Very well made stuff, very well made. This is custom made stuff here. Rectifier, filter capacitors, Germany, GPF, there's a microfarad 25 volts. Very good quality stuff. The possibility could be in here. A slight bit of dust or something in one of these cards is causing it to be a bit intermittent, which is possible. Because this has had a bit of leaves and tree leaves and stuff sucked into the fan. Because this would have been used on the field outdoors. So it's possible dust would have got into one of these little connections inside those sockets somewhere to cause it to be a bit intermittent. Just needs a bit of TLC, as I said. There's nothing really wrong with the unit as such, because the first repair I did on this was only the bolts, the screws, they were loose. Then I'm going to do an in-depth repair, and yes, it's definitely made in 1988. There's another date code on that, 7th, 17th, 1988. The soldering is all good on this thing. This is all custom-made stuff by the SEC, the brains of that computer. Under that little blob, in that little hole there, is a chip itself inside this package. Yeah, like a little square thing with millions of gold wires coming off it. There's a silicon chip inside that. It's just in that, under that little bit there. And there's millions of gold wires coming off that chip. Goes to all these pins on this package. Got some transistors on this thing. Flip it around. Wire my capacitors. Singaporean made chips. I like the sockets, very well made and high quality stuff. Crystal, some more transistors. Korean made Fairchild there. Double sided, yeah, it's double sided this one. They look pretty damn good in there, but I'm going to give them a good clean anyway, just to be sure. Power supply goes in that last one. Here's all the calibration bits and pieces on here. 1.239 mega ohms. Little calibration trimmers on this thing. This will be the calibration part of it for the calculations of the error and everything. Yeah, very well made. Soldering's good too. Bit of smearing on that one though. I can see someone's fingerprint on there. I might give it one a bit of a clean. If I want to do that, I'm going to take note which one goes where. Get my contact cleaner and I'll start giving those sockets a bit of a clean. Bit out of stuff there. That's a bit too much, but these are isolated and been off for a bit, so it shouldn't hurt them. I'll just do a bit of buff for the rag if I need to. Anyway, I'll do that and put it all back together and see what it's like. While that was still dripping wet with contact cleaner, I'd plug them in their sockets to give them a bit of a clean at the same time. So it should be okay. Then the zip ties got to go back through that to hold these boards in place. Especially with these sorts of cards, you got the low voltage sensitivity in the communications part of those chips. The slightest bit of dust or fingerprint in those connectors can cause the computer to be a bit intermittent like that sometimes. So it's not so much the capacitor that's dried out or a dry joint anywhere. It's possibly that. I'll give a careful look at the socket again. And it's that socket I'm talking about. There is it. In here, okay. It's very well made, this thing. Keyboard in there. Yeah, they're all very well secured in there, so it's not that. We see some unused wires in here. Wonder what they go to. Optical sensor. Optical sensors in there. It's only got a couple of wires on it, but these, whatever function this thing has, is not used. goes here somewhere. They're not used. Oh, they go in here. Well, white, orange and yellow on this go onto here on this selector wheel. So it's in this function here. Maybe we've got this function wheel only does a certain amount. Because some wires are connected on that, so it's how it works, but it's not necessarily that you don't use this sort of time in the most meters, but it's, I think because it's a decimal, so it only goes to a certain part and that adds up as a certain number in the computer. So they go into there, to these bits here for the scope, to the B and C, they're coax, little coax cables. I think they're all part of the calibration, I think. Here we've got the computer and here we've got the power supply, the main brains of the circuit, and the other half for the computer itself. And this is all the part of the phantom loading circuit. It goes to the off out of a big current transformer. It loads up through these resistors, then to the meter. This is part, must act as a resistive ballast or something for certain meters. It's very well made head of laid out. That's what the fan's for. The fan keeps this bit cool because they're obviously going to get pretty warm with a current going through them. Anyway, I've done all the checks I need to do. Fingerprints cleaned off, sockets are clean on these cards here. The soldering is good, the wire connectors are good, so I don't see why it wouldn't be intermittent on some functions. That's all been checked up. Anyway, let's whack it back together. Hey, all the functions on it might work good now. Now it's ready for a test. Beautiful. Meters on its mark, it's still another kilowatt hour test. Press the yellow button. I did, it's going. Beautiful, look at that. There you go, it's little I do like the layout of old vintage computers though from the 80s era. It's quite nicely made. There you go, there's a dodgy fingerprint connector on one of the computer cards in there. The fingerprints cause a bit of glitching and intermittency on the computer. That's why that function wasn't working properly. And some of the percent error wasn't going into that menu, it just stuck on ready. No matter what I did with that top button, it wasn't bloody working. A bloody fingerprint, eh? Damn, has that made a noise? I let it go for a kilowatt hour. It's going to get back to this mark where I left off again. I wonder what it's actually counting. 0.017, well we've done 100 watt hours. That should be 0.01 kilowatt hour. It says 0.02 now. Interesting how that works. Anyway, let it go for that test again. This one flat out. Anyway, I'll use an update after the end of this test. See what number I get this time. So it's counting up the kilowatt hours. Everything's all been set. Anyway, damn is that noisy. Oh well, it was a bad wire after all, you little buggers. Okay, this yellow wire was snapped off. It's supposed to go on this top pin here. Solder's on there like that. Gee, it wasn't very well soldered on, because that top button is held in by the cutout on the circuit board here, and it was bent with such force, it must have been barely holding on. That's barely, it's going to go on there. So it was that, well, that's our problem we're having. It wasn't in here at all. It was that. Because that top button was not working at all. But only on some functions. It explains I've got two wires which work, and this wire here is a select wire for the that runs that percent error function and this dial test function. This wire here was our culprit. I better resolder that. This Hammond brand enclosure made in Canada. Man, this is some very well made stuff. The switches are made in Denmark. That's some high quality stuff. Done. Bad solder connection, that's all it was. Enter. Beautiful, look at that, it works. Beautiful. I tried a plus one this one. So if I have that going, press it again, it should start counting. Look at that, eh? But it works. Start counting. It's on. But I didn't count the disc revs. Whoops. I've got to count the revs of that disc, don't I? Start again. That's it. Oh, well, I did a minute error test. So enter that. That's been done. Now when I turn the switch on, it will count properly. So 3, 2, 1, bang. One turn, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bang, off. 2039. Right. This reading is errored. So 2039 now. 2039. Yeah, it's got a plus one there too. More reliable now. It's a bloody loose wire in there. That button wasn't working properly all along. Bloody loose wire. It's fixed. I'm happy with that. Because this thing here was pixelating too. It just went blank, and a black line here with all the solid dots. So that wire was shorting out on something inside. And when I moved it around and tapped it, it went good again. So it was a loose wire all along. Anyway, that's fixed. That's better. Now I think I got this worked out. It's a bit of mathematical things to get your head around, but using this example, I just adjusted it for my particular meter situation here. So I had that number 499.9, which would have been in here, divided by 2039. Then work out the percentage from there to get the percentage error, and ended up with 2.45%. So 2.4 might be 2.45% error on this meter. So it might need a little bit of recalibration because of the vibrations, but it's only the tiniest bit out according to this calculation. It's 2.44% error on that meter. But this button works really well now. Nothing wrong with this thing at all now. Was that bloody loose wire in there all along? It's a great repair job. Anyway, now I'm not 100% sure if that the equation, my calculations are correct, as I am still learning this side of it here. Because I have to allow this and modify the calculation a bit for single phase, because it doesn't have this formula for the single phase one. This is for polyphase meters, like the SDs, where you have to take into account 2 phases you have to put into the equation here. Here I've only got 1 phase, so I have to modify the formula a little bit for 1 phase here. So it's giving me a reference number and everything. So yeah, based on what I could figure out, my calculation was 2.45% on that meter. Anyway, I am still learning all this thing, but once I get my head around it, I'll come up with my own formula here, write it down on a bit of paper like I remember it, and use it for all my single phase meters. It's pretty straightforward, self-explanatory now. Anyway, that'll be enough for now. Thanks for watching.